Morning. This is lesson 7.07 for chemistry, mole conversions. This time we're going to do conversions with compounds. Back in chapter 3, we converted between atoms and moles and mass for elements. So we looked at what would happen if we had an element, and we wanted to look at the mass of an element versus the number of atoms using mole as a conversion factor. Going to do the same thing here, but now we're going to do it with compounds. And remember, usually we say the smallest piece of a compound is a molecule. So now instead of converting atoms to mass, we're going to do molecules to mass. Well, does it matter for moles? No, remember a mole is 6.02 times 10 to the 23rd in terms of count. Anything. 6.02 times 10 to the 23rd of anything. So this could be pencils, this could be pieces of paper, this could be mugs of coffee. We could have anything. So if we change from atom to molecule, it does not change Avogadro's number. What does change is how we find the molar mass, which we did in the last video. So here we're going to go from number of molecules conversion. We're going to go to moles. And then we're going to go to mass. Remember, to convert from a count to moles, we use Avogadro's number. I'm going to abbreviate here, Avogadro's number. And to convert from mole to mass, we're going to use molar mass. Now, we just talked in the last video about how we find molar mass, and we said that the molar mass is the sum of the masses of all the atoms in the unit of grams per mole, in grams per mole unit. And that's implied as grams in 1 mole. So I think the easiest thing is to just jump through some sample problems, and you're going to see this is very similar to what we've done before. So we have, what is the mass of 3.04 moles of ammonia vapor? So what we did last time was we framed up our problems. The problem gives me 3.04 moles of ammonia vapor. That's over 1. And I'm going to mass. So remember, we can use this diagram to help us figure out what we're doing. I'm starting at mole and I'm going to mass. So what do I need? I need the molar mass of ammonia. So I'm going to make my element bank here. I've got a nitrogen, I've got hydrogen, I've got 1 of these, and I've got 3 of these. The mass of nitrogen is 14. Mass of hydrogen is 1, so this is 14 and 3. When I add that up, I get 17 grams per mole, and that's in 1 mole. Now, if I write this as a conversion factor, I get 17 grams of ammonia in 1 mole of ammonia. Those are the same thing. Remember, grams per mole is the grams in 1 mole. Well, that's my conversion factor. Can I put it in like this? What do you think? Did you say yes? I have moles on the top. Here I have moles on the bottom. So I'm going to put this in as 17 grams NH3 over 1 mole. So we framed up our problem. We assembled our conversion factors. We inserted our conversion factors. We still have the steps of dimensional analysis. Do you remember what the next step is? Did you say cancel units? Make sure you're on the right track. And when you multiply 17 by 3.04, which is our last step, you get 51.7 grams of ammonia. NH3. All right, what if I want to go from molecules to mass? So I start off, I've got, or mass to molecules, I've got 3.82 grams of sulfur dioxide. It's over 1, and I want to go to molecules. So I'm framing up my problem. All right, let's look at our diagram. I'm starting at mass, but I'm going to molecules. How many conversion factors am I going to need? I'm going to need 2. First one I need is molar mass, and the second one I want is Avogadro's number. So I'm going to need my molar mass. Let's make an element bank. I've got sulfur, I've got oxygen. I have 1 sulfur, I have 2 oxygen. Molar mass of sulfur is 32. Oxygen is 16. I'm going to have 32 plus 32. And my molar mass is going to be 64 grams of sulfur dioxide in 1 mole of sulfur dioxide. Okay, the other conversion factor I'm going to need is Avogadro's number. Well, this really hasn't changed. We're going to say that there is in 1 mole of SO2, 6.02 times 10 to the 23rd molecules. So I'm going back through my steps of dimensional analysis. I framed up my problem. I've assembled my conversion factors. Now I need to insert them. I have grams on the top. So which factor do I need next? And how do I have to put it in? Did you say this one? And I can't put it in like this. I have grams on the top. So I need to flip and I need to put grams on the bottom. So this is going to be 1 mole of SO2 over 64 grams of SO2. Okay, I've used that conversion factor. Now I'm going to put in my moles to molecule. I've got moles on the top, so moles has to be on the bottom. So I'm going to flip this. 1 mole of SO2 is 6.02 times 10 to the 23rd molecules. It's a 23. All right, let's check to see if I set it up correct. Grams cancels, moles cancels. I'm left with molecules, which matches what I have on that side of the problem. Last thing to do is multiply and divide. I'm going to take 3.82 times 6.02 times 10 to the 23rd and then divide that by 64. Remember to get this punched in your calculator correctly. That can be the biggest problem. And when I get my answer, I find out that I have 3.59 times 10 to the 22nd molecules. 3.59 times 10 to the 22nd. So this isn't anything new. It's the same thing we did back in chapter 3. The only difference is now instead of just using the elemental mass, I have to find the molar mass for the compound, but everything else is the same. All right, I hope this all came back to your memory. That's all for this video. Thanks for watching.